Good day everyone, and welcome to Island Technologies presentation on Quality of Service or QoS in DRATEC routers. My name is Java and I'm a technical sales specialist here at DRATEC Australia, New Zealand. Here's a quick view of what I'll be covering today. First up, we'll look at what quality of service is and why we need it. Next, we'll look at QoS in DRATEC routers and the configuration options available. And finally, we'll go over a couple of QoS configuration examples. If you have any questions during the video, simply comment in the chat box that's on the right side of your screen and stick around at the end for a 5-minute Q&A. If you're watching this after the live premiere, simply comment below or send an email to sales@dratec.com.au. All right, so it's time to begin. Let's start by looking at what quality of service is. So we define quality of service as the ability to provide priority to different applications, users, or data flows, or to guarantee a certain level of performance to data flow. What this means is that some applications or data flows cannot be delayed or interrupted, or in a busy network when one application may be more important than another. For instance, your VoIP traffic cannot be interrupted since it occurs in real time, and it gets difficult to carry out a conversation if the voice transmission keeps dropping out. Another quick example would be that access to your finance systems is definitely more important than browsing Facebook. So we'll quickly talk about the need for quality of service. We need to look at what factors influence data flow. These are reliability, delay, jitter, and available bandwidth. A lack of reliability usually means that data packets can be lost. For TCP/IP communications, it will result in slower transmissions since the packets have to be retransmitted. But for UDP packets, which is used for VoIP communications, it will result in dropouts, which will cause broken audio. Next, a delay in data flow will be noticeable for real-time applications such as VoIP. The other factors influencing data flow are jitter, which is a variation in packets belonging to the same data flow and bandwidth requirements. Some applications may need more bandwidth than others. For example, a video stream will require a much higher bandwidth than a web page. And insufficient bandwidth usually results in buffering and a stop-start video stream. In IP networks, QoS is used to prioritize critical traffic over non-critical traffic. For example, you may want your VoIP traffic to have a higher priority than email or HTTP traffic. Also, since the internet is a best effort service, there's no guarantee that packets will not be dropped due to congestion or be unduly delayed. Real-time applications such as VoIP, video over IP, will work okay when sufficient bandwidth is available, but during peak hours, network congestion will result in increased packet loss and delays resulting in degraded VoIP service and so on. Let's look at QoS implementation in DRATEC routers. In DRATEC routers, there are two key components used in the primary configuration of QoS. These are classification, which is used to identify low latency or crucial applications, and marking them for high priority service level enforcement throughout your network. And the other is scheduling, which is based on the classification of the service level, so it can assign packets to queues and associated service types. In DRATEC routers, the primary configuration of QoS is effective under heavy traffic load conditions. For example, if your WAN connection becomes congested, then data requiring priority has to compete with other data. DRATEC QoS will dynamically allocate the required bandwidth for high priority data. I'll be going over the configuration options for this one later. Also, QoS should not be confused with bandwidth rate limiting, which has the effect of slowing down some PCs but does prioritize data traffic. For large-scale network implementation of QoS, the usual method is to use DSCP, that is Differentiated Service Code Point, and IP precedence at layer 3. With DSCP, you can create 64 classes, and it's backwards compatible with the legacy system, which uses type of service or TOS field in the IP header to define 8 service classes. Differentiated Services, or DiffServ, provides a method to classify and manage network traffic to provide quality of service in IP networks. DiffServ uses a 6-bit DSCP in the 8-bit Differentiated Services field, also known as the DS field, in the IP header for packet classification purposes. The last 2 bits are currently unused. Now, this diagram shows a QoS-enabled network or DiffServ framework. Here, each network provider has an agreed service level agreement to guarantee the end-to-end network service level. So, the appropriate QoS settings have to be enabled across the entire network to give priority to a particular type of network traffic, such as VoIP. Each DS domain will prioritize this traffic. This is called per hop behavior, or PHB. An example of how Telstra prioritizes VoIP traffic over the NBN. They use DSCP 46 to tap VoIP traffic across their network, and for VoIP class traffic, it only recognizes DSCP markings 40 to 47 decimal, and unrecognized packets are simply dropped. PHB, or per hop behavior, is a term used in differentiated services. It defines the policy and priority applied to a packet when traversing a hop, such as a router, in a DiffServ network. Here we have some examples of DSCP bit settings. All zeros is used for best effort. The definition of PHB includes expedited forwarding, or EF, assured forwarding, that's AF, and best efforts, that's BE. In the table shown here, you can see that assured forwarding defines the 4 classes of delivery or forwarding and 3 levels of drop precedence in each class. These are low, medium, and high drop. The combination of classes and drop precedence gives us 12 separate DSCP encodings from AF11 through AF43. If congestion occurs within a class, the packets with the higher drop precedence are discarded first. Prior to DiffServ, IPv4 networks could use the precedence field in the TOS byte of the IPv4 header to mark priority traffic. The first 3 bits are the precedence bits, which are mapped to a DiffServ class. So we have CS0 equals IP precedence 0, CS1 to IP precedence 1, and so on. So if a packet is received from a non-DiffServ aware router that uses IP precedence markings, the DiffServ router can still understand the encoding as a class selector code point. Here we have a couple of DSCP values. DSCP 46 is used for high priority traffic. It's often used by ISPs to handle VoIP traffic over the internet. And at the other end, we have DSCP value of 0, which is for best effort handling over the internet and can be used for low priority traffic. DRATEC routers have 20 pre-configured DivServ code points that can be selected for the QoS setting. These include 7 IP precedence classes and 12 AF classes that were discussed previously. The EF class is at the bottom of this list. I'll now briefly go over the configuration options for QoS in DRATEC routers. For DRAOS routers such as the bigger 2865 shown here, the QoS settings are done under the Bandwidth Management Quality of Service configuration menu. You'll notice that there are 4 sections in this page. In the bigger 2865, we also have App QoS as shown here. This is a list of predefined applications and tabs for traceable and untraceable. We just need to select the required application, then select the QoS class to be assigned to them. Under the traceable category, we now have a much greater list of applications compared to earlier model routers. The categories listed include instant message, VoIP, protocol, tunneling, stream, remote control, WebHD, game, Google services, Amazon services, and eLife. Under the untraceable category, we also have a much greater list of applications compared to early models. Untraceable apps are not easily traced by the WiGA router. Let's take a closer look at the configuration menu options. At the top, we have the General Setup menu. Here we can configure QoS for each WAN interface. You'll notice that we have 4 categories for bandwidth allocation: Class 1, Class 2, and Class 3, as well as others. For each WAN interface, you can adjust the percentage of the bandwidth to reserve for each class. The default is set to 25% per class. And you can make changes and tweaks as long as the total value adds up to 100. Also note that the bandwidth allocation is dynamic. So if the reserved bandwidth is not required for the specified application, it will be used for other internet activity. Clicking on the WAN link as shown here will bring up the UDP bandwidth control. Since VoIP services use UDP, it is not recommended to enable this option as it will seriously impact VoIP communications. You'll notice that you can also select the direction for QoS control. This can be in, out, or both. The next section in the Quality of Service config menu is the class rule. Clicking on Add will bring up a menu where you can enter the required details, including QoS class IP addresses to be included and the service type DivServ code point. There are a number of pre-configured service types from the pull-down list that can be selected. If the service type required is not on the list, you can create your own by clicking on the user-defined option. Once you select user-defined, you will see extra options to define the service name, protocol, and port number. This will then be saved as another service type in the pull-down menu. There's also a pre-configured option to enable QoS for VoIP traffic. All you need to do here is just select the checkbox to enable the option. There's no need to create a rule for one of the classes. Clicking on the green icon will display the VoIP QoS status for attached devices. An additional feature in the QoS settings is the option to tag outbound traffic as shown here. You can select the diffserv code point or precedence value from the pull-down menu. Now, for QoS to work correctly, the router needs to know the actual bandwidth of the WAN connection. For ADSL WAN connections, the router can work out the actual upload and download speeds. But for Ethernet WAN connections, the router may be connected to an external modem, which may provide much lower bandwidth than the capacity of the router's WAN interface. So here we need to enter the actual upload and download speeds. You can determine the actual speed by running a speed test or using some other utility. It's best to run the test a few times to get an average value. Then take 80% of that average to be entered into the router settings to maximize QoS performance. There's also an option to add QoS in firewall rules. Here you can select the required QoS class for the firewall rule. I'll now go over a couple of QoS configuration examples. This example is based on one of the application notes in the Draytech knowledge base. There's a link down the bottom there, which I'll also include in the video description below. So here we want to set up QoS to reserve bandwidth for a VPN connection. We want to give priority for traffic going to the FTP server 192.168.20.11 shown on the right from the 192.168.10.1 subnet that's shown on the left. The first step would be to log into the VPN client router on the left. Then go to the bandwidth management, quality of service config menu, and edit class 1 in the class rules. Next, we need to select Enable to activate this rule and click on Edit to enter the local IP subnet address, that's 192.168.10.0. The next step will be to set up QoS settings. We select direction, WAN speed, and bandwidth allocation for the rule that we just configured. Also, we've reserved 55% of the available bandwidth for class 1. Once this configuration is complete and the VPN is up and running, we can click on the status option to look at the traffic details. What we should see is that traffic for the VPN class will appear as the green bar shown here, indicating the amount of traffic being prioritized. Another example where we use QoS settings is in WAN traffic shaping. Some ISPs require users to enable WAN traffic shaping on their routers to limit outgoing traffic to match the data rate that they've purchased. For example, if your data plan is for a 50/50 Mbps Ethernet service, then any outgoing traffic that exceeds 50 Mbps will be dropped by the service provider. As a result of the outgoing data packets being dropped, the user will notice that the actual data rates will be similar to 50/20 thereabouts. All right, so here are some key messages to take away from today's presentation. Quality of service is an essential feature to ensure that some applications or data flows are not interrupted. Data flow is influenced by many factors. QoS can prioritize critical traffic over non-critical traffic, for example, your VoIP calls compared to general web browsing. There are two components for QoS in Draytech routers, that is classification and scheduling. Large-scale QoS implementation uses differential code point or DSCP. Okay, that's it for me, but please do stay tuned. Staff's going to be answering questions in the live chat on the right of your screen for the next 5 minutes. And for more information about Draytech products, please check out our website at www.draytech.com.au or send us an email to sales@draytech.com.au or give us a call on 0298 388 99. Don't forget to like and subscribe below, and if you'd like a notification of new Premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thank you very much for your time today. I hope that you found this session informative. Until we meet again, goodbye.